Okay, so I think now it is okay. It should be recording the meeting at this moment. I am now recording the session, but I made a small explanation in Japanese to begin with. My name is Jaco Diez, and I'm the professor in charge of this subject called in Japanese画像処理特論, which would be image processing, basically. Special lecture in image processing. And today we are doing our guidance session. If any of you, as I said before in Japanese, has problems with the English, just let me know and I will provide support material in Japanese. Most of the contents of the course are already provided in Japanese, but if you need anything else, just let me know. I'm going to today just speak a little bit about what we will be doing in the subject, and hopefully, if I have time, we will also be doing a little coding today. Okay, this is a master's course, so on the one hand, the level is pretty high. On the other hand, we have a bit more freedom than with undergraduate courses. Okay, so if you're interested in anything, many of you are already thinking about your master research and so on. If you're interested in anything in particular, tell me, let me know, and I will do my best to reflect that in the course, maybe in the general materials, or maybe in assignments that I can give you. So probably you can devote more energy to working in what you like. Okay? I will start the presentation now, but basically in this subject we will try to learn to program, to code, not just to be very good coders, but to use that coding for something practical. Okay? For many of you, it will be your master's thesis, but if you're interested in other subjects, that's also okay. Because of that, I will do my best to show as many practical content as possible. Okay? If you're a beginner and have never programmed, don't worry. You still can take the course. Okay? It will be hard because you will have to catch up a little fast. So you will need to dedicate quite a lot of time to this. If you're already a seasoned programmer and can already code very well, don't worry either. Okay? I will do my best to provide material at different levels. Okay, let's start with first, before the presentation, let's have a look at some things in web class so that we know what we have there. So I'm going to move this to that screen and start sharing my screen. So let me find it. Yes, sharing. That's great. Okay. So just to test that not everyone went to sleep and you're more or less following, can you see web class in that screen? Okay, I need an answer. Can someone answer? Can you see web class now? Minna, web class 見えますか? Not many answers at the moment. You should be able to see web class now here. みんな、こんにちは。web class ちゃんと見える？こっちには画面でシェアをしたと、それは大丈夫でしたか？
見えます。
ありがとうございます。 So we can see web class. Thank you very much. Oh, someone gave me a thumbs up. Sorry, I missed this one. Okay. Thank you very much. It's for those seeing it later, this is Monday morning, first hour in the week. Okay. So it's always a tough time. So thank you very much for keeping here and for staying here and for answering. So, as I was saying, we are seeing now web class, and we have here the announcements, okay? We also have an overview of the subject, a link to the coding courses, and the start questionnaire, and the first code project, okay? So I suggest that all of you give this some time and read it. You can do it while I'm speaking, no problem, okay? Do the questionnaire where I ask you some questions about your coding ability, English, interests, okay? I will show you a lot more about the coding courses later. And here you have a bit of a subject overview for those who want to know in a little more detail what we will be doing. But I will also go back to this during the presentation. For now, let me go to the announcements. Okay, there is a questions forum where you can post your questions if you have them. And I wanted to show you the updates post. Okay, here you have plenty of information, and I will do my best before each session to provide a general description of what we will do and necessary links. For example, most of you already found the Zoom link here for this session, and I will post the Zoom link for all the sessions here. This is the second time that this course is being done in this exact format, okay? So we have the benefit of already having the sessions from last year. So if you click here, you can open and see a video with the session from last year, okay? So if you want to prepare the session, you can have a look at the session from last year. Maybe you already know, so you can sleep a bit more until late on Monday. I don't recommend it. You can be here and you can ask questions, okay? The other thing is just a video. Most important for this 2026 edition of the course. All the sessions will take place like this, online, okay? I am physically in Yamagata City in Kojirakawa campus, room 302. And you can all contact me via web class, via email, at any time. I will do my best to answer quickly, okay? There is also a link posted to a Slack channel, okay? Which you can access to ask questions whenever you want. Okay, I'm not seeing the Slack channel here. Here it is. Okay, this is a link to join the Slack channel where you can ask questions that Slack channel I look at quite frequently. So if you ask questions here, you will get a faster answer. Okay, so do have a look at this course in general. If you're in Kochirakawa campus, you can also just email me and we can meet. Okay, we can find a time. Mondays is pretty good, not after the class, but in the afternoon, I will have probably time to meet with you, okay, in person. If anyone needs an online session of questions and so on, just ask me, okay? Okay, that's the general working of the course. But next week, Monday, we have an exception. Just as after I finish this class and the next one, I will be leaving in a work trip, okay, for about 10 days, going to Girona in Spain to try to build international networks for data science research. And because of that, next Monday, I will not be able to teach this class normally. So you already have all the materials for that session there. You have the video from last year, and you have all of the notebooks that will be used on the session. Okay. If there is anything that's not clear, you can ask me at any time during this week, during next week, and I will do my best to answer. But next week, Monday, there will be no online session. Okay? Okay. I will not speak about it today, but the final thing that you can see in web class is the first code. I will say that the subject is evaluated from 3 code projects, and you already have the first one. Okay? So do have a look after you have seen the materials for session 1. This is session 0. This is the guidance. Session 1 is next week. So after you have done that, go and have a look to this one. Okay, so that's all of the pantry, all of the admin material. Now, let's start with the presentation. If anyone cannot see the slides now, just let me know, okay? But this is the general presentation for image processing for this course that we are starting today. I'm going to give an overview. I'm going to talk a little bit more about me, just a little bit more, and about the things that we can do with this. And I'm going to go back to this thing about the different levels of the course. Let's go. So my name is Santiago Diez Donoso, although everyone calls me Yago, which is a shorter name. And most people around here call me just Yago Sensei. Personally, I don't mind. Some people are more formal and like to call me Diez Sensei. That's also fine. But generally, Yago Sensei is absolutely okay for me. No offense taken. Okay. What I do in Yamagata University, where I have been working since 2017, is data science. And data science is a little bit difficult to define because it's very wide. There are many things that are considered data science today. So I like this diagram that I found on the internet a few years back to explain it. This guy said that data science is what happens at the intersection of math, programming, and some expertise in some field. Okay, I will call this the application field. If you have lots of hacking skills and math and statistical knowledge, this guy says you're doing machine learning. It is okay. If you have lots of hacking skills, coding skills, and you are good at some area, that guy says it's dangerous. I don't know why. But the main point of this diagram, expertise and math and knowledge, this is science, according to this guy. But when you can do the 3 things, when you are good at coding and can do math and statistics and then have some knowledge in some application area, then that's when data science happens. Okay. I do not have all of these 3 things. Okay. I have some coding skills, I have math skills, and I don't have much substantive expertise in other areas. Just a little bit. Okay. But that's not a problem because usually this data science happens in teams. So what I'm trying to help you become is someone who can work in one of these things. And I'm going to try to give you some more skills, help you achieve some more skills in this hacking part. And we will speak about the math statistic minute of all of it during the subject 2. Okay, I originally come from a village called Banyoles in Spain, in Catalonia, okay, which has a beautiful, nice lake. And during my formative years there, primary school, high school, I learned, of course, high school math, among other things, and I also learned programming, a little bit of programming in high school. Actually, I got to do something like Connect 4 game during that time, which was my first taste of something slightly applied just to a simple game. in programming. Afterwards, I went to university in Barcelona. Okay, this is a view of beautiful Barcelona city, which is known for many things. It's for football team mostly, but also some very well-known buildings like Sagrada Familia. And I'm realizing this photo is a little bit old because here the whole thing is still under construction and it was finished a couple years ago. So I really do need to go and change the photo. Okay. Of course, I studied mathematics at university, so I got much better at math during those years. Okay, I also did many other things, but did study quite a lot of math and quite a lot of programming too during that time. Got some experience in some things. And then I went and did my PhD in Girona University, where I worked in many, many things, mostly computer vision and medical imaging. Okay, but since the beginning, since I finished my PhD mostly, I did a bit of a theoretical PhD, but since finishing it, I started working on applied projects. Many, many different applied projects. For example, 3D point cloud matching. Using data acquired from some sensor, and for example, that included the Kinect console's motion capture sensor. We built theoretical 3D models of objects. This is a famous bunny called the bunny figure, called the Stanford bunny, and we used the 3D point clouds of that bunny to reconstruct the whole object from different views. You take one view and part of the bunny is not reconstructed because it's occluded or it's too far away or something, and you take another that reconstructs a little bit more and you join those two views and you have a little bit more of the object. And you do that many, many times and you end up with a full object. I also did lots of medical imaging during that time. For example, here we have images of the brain of one person suffering from multiple sclerosis. Multiple sclerosis is a very severe disease, and it progresses by creating lesions, small zones that are hurt in the brain. And the most important, well, one of the very important parts in the treatment of this disease is knowing if these lesions are growing, if new lesions are appearing. So we used image registration to put two images together of a scan taken at one time and of the next scan taken 1 year later. And we put these two images on the same position to see if we could find newly appearing lesions. The same for X-ray mammography. With this research, we also took scans taken at one particular time of someone's breast and 1 year later, and we strove to find newly appearing formations. Okay, and then give this information in the best way possible to doctors to see if that meant that there was some anomaly, some cancer, for example, or some other illness appearing. So with all of that, I advanced on my data science skill set. And after my first postdoc in Girona, I came to Tohoku University in Sendai. I came in 2015 and stayed there for a couple of years in the informatics department. In 2017, so almost 10 years now, I came to Yamagata. And sorry, I didn't get a prettier picture, but I think because I come by train every day, that's the building in Yamagata that's more in my mind. That's Yamagata Station. Okay. So since I have been working here, I have been trying to find new research collaborations in data science, okay, within the university, within Yamagata Daigaku, and with other universities. And that's going, I think, pretty well. So I do have lots of collaborations in Japan, within Japan, okay? As you will see in a second, a lot of them with the Faculty of Agriculture in Yamagata University, but also Tohoku, Iwate, other universities too, okay? And I have active collaborations with lots of other researchers, international researchers in many places. I actually am working with people in Mongolia too, and I have not added this to the map, okay? Mongolia, sorry. And researchers in Australia, in Sydney, sorry, Mongolia. I was not finding Mongolia, and it's pretty big, okay? Mongolia between Russia and China, not in China, Mongolia, okay? Lots of research recently with one project funded by JICA, by the Japanese Agency for International Collaboration and International Development. Okay, something that if anyone is interested in, just let me know in the questions and I can explain a little bit more about. There are many, many international projects happening in Yamagata University, and I'm sure if you're interested, you can participate in them too. Apart from Japan and Mongolia, which is not marked on the map. I have collaboration with some people at Sydney and lots of collaborations with people in Europe. Okay. I'm going to Girona today after these classes, but I'm also working with researchers. Okay, I also don't have Italy. In Italy, in Turin, in Germany, um, the Netherlands, okay, even Croatia, lots and lots of collaborations. Need to update the map quite clearly. And all of these collaborations have resulted in many different research projects, papers, as you will see in many of the notebooks that I will use in the course, that we will see during the course. Because this data science thing is more of a way to process data than actual research in one single area. Okay. For example, I have used recently deep learning networks to classify images related to this type of documents. These are Wasan documents, which are a type of Japanese mathematical text from the Edo period, which are very special. They are characteristic to Japan in a moment when Japan was not fully holding diplomatic relations with many countries in the West. It was still communicating plenty with China and Korea and all of the neighboring countries, but not so much with Western countries like countries in Europe or the United States. And because of that, some of the scientific and in particular mathematical advances happened in parallel to advances that were happening in those countries too. So this is idiosyncratic, this is specific, special from Japan, and it's a very important cultural asset that Waki Sensei here, Professor Waki at the Faculty of Science, is working to preserve for further generations to study, and we are trying to join, to marry this ancient Japanese expression of culture with modern data science and artificial intelligence techniques. And I will explain to you a little bit more about those. But these same techniques can also be used for processing other types of data. For example, all of the data that we are processing with the people from the Faculty of Agriculture, with Professor Larry Lopez, and students from Turin University will know Professor Lopez because he's one of the main responsible persons for the establishment of the double degree with Turin University. So if anyone, not only Italian students from the double degree, anyone is interested in this type of drone image processing, you're also welcome to ask. Okay, this will 100% be part of the course because some of the data used in project 3 is from here, project 2 too. I'm still thinking about whether or not to use the WASM data also for project 3 if someone is interested. So if you really like WASM and are interested in document processing, let me know, and that will increase the chances of that. As I said before, we have a bit more freedom in master courses. So if you're interested in something, let me know and I will see what I can do. Okay, so that was a little bit for the presentation. You have the questions if you want to ask for more details, if you want to tell me something about something in particular, okay? I wanted to speak about this slightly different to what happens most of the time characteristic of this course. This is a course at different levels. What does that mean? Well, that means what it says in the tin. The course can be followed at different levels. So if you are a beginner, you can follow the course. If you have, I'm meaning in terms of programming, okay? If you have never programmed, you can follow the course and you will get some content. And I will go into detail very soon, okay? I already talked quite a lot about language. Main language of the course is English because of this being an international course, but Japanese is also supported, okay? Si alguien prefiere tener el contenido en español, también es posible. Fins i tot en català. Okay, so if anyone prefers support in Spanish or Catalan, that's also possible. Okay, just let me know. The grading will be done from these 3 projects that will be handed in at regular intervals. So you're expected to code at home and to submit the projects. I will explain a little bit more about them later. But basically, these 3 projects will make up the whole mark for the course. I will say here too that these 3 projects can be submitted before the deadline, and I recommend heartily that you do. There will be a deadline, there will be a time after which you cannot submit the projects, okay? So if the date is, let's see, let's go back to WebClass 1 second. So this project, the deadline, unless I change it, but I don't plan to, is 4th of May, okay? At 11:59 in the evening, okay? So you cannot submit this on the 5th of May. If you do that, I will not accept it, okay? So deadline extensions do not happen unless there is some very urgent medical reason or something. I had a flu the last day and I couldn't submit it. It's not going to cut it, okay? So if you were in hospital because something terrible happened, maybe. But in general, there are no deadline extensions. So submit this before the deadline. Make sure that that happens. But if someone has a look at this today and wants to submit it today, that is allowed, okay? I will do my best to grade it and to give it back to you, to give you feedback. This part was okay, this part was not so good, okay? So if you want to work beforehand, you can do it, no problem. Because all of the materials of the course are already online. If you're not busy this time of year and you want to look ahead, advance, look at the videos from last year, look at the notebooks, you can do it. No problem, okay? No problem absolutely from me. And you can get ahead of all of this. You can even submit the first project, okay? Second and third project will be published later, but you can also do those earlier. As I said, you can submit it early before the deadline. I will do my best to reply within 24 hours and then give you feedback, and then you can submit it again as many times as you want. So if you want to make sure that you pass the course, generally good strategy is to read the projects, try to do your best, submit all that you have, get my feedback, fix things, go on. Okay? Let's go back to the presentation. ChatGPT, AI tools, can I use them to do my homework? Well, no, please don't. The reason for this, and I will get into it a little bit later, is that, well, that would be a pretty silly thing to do. I'm not going to police this heavily, okay? If I see a code that's absolutely completely done with an AI tool and the person has not understood what the code does, okay, I will fail that person. That person will fail the course 100%. I will decide if that code is AI generated or not. I might ask the person to explain the code, and if they can't, they will fail. If the code is obviously wrong, the code doesn't do what it should do because the AI tool was confused, the person will also fail automatically. Okay, so that's one reason for not doing your coding work with an AI tool without understanding what you're doing. Second reason for not doing your homework, your projects with an AI tool without understanding. Well, you're supposed to be here to learn. So if you let the AI tools do the work for you, you will not learn. And if you are hoping to use your coding skills to in your job, in your research, you will be wasting your time and mine. And I would prefer you not do it. Okay? Also, coding tools are not very good at coding. Okay? You will hear news saying, okay, no more coding is necessary. AI is doing all the coding work. That's not true. Coding tools are getting better. They can do some of the work, but they cannot do anything original because of the way they are designed. And we will talk about this a lot in the third part of the subject. Okay? And in particular, they cannot do slightly complicated code. So they will be able to do some part of the coding for this course, but some others not at all. Okay? Are AI coding tools useful? Sometimes they can be. If you're learning to program, my recommendation is that you do not use them at all because they will not let you learn. They will serve you code that's not adequate for your level. They will confuse you with explanations that make no sense. So if you're just a beginner, my recommendation is that you do not use them at all. They are not forbidden. You can use them if you want to. That's your decision. But you have to understand what you submit. Okay? If you're an advanced level programmer, be careful. Most of the time, they will not make you faster. Okay? There is a recent study that says that actually they can make you slower. They give you the sense of I'm going really fast, I'm coding really quick. Most of the time, it's not true. Okay? I am doing my best to learn to use these tools, to see what utility they have. In my opinion, so far, boring tasks, repetitive tasks that can be checked instantly, like build me a table with these numbers or build me a graph with these numbers. That's quite easy to do, and I don't relish the opportunity to go and find what the name of the function that does that is. Okay, so maybe for that. Maybe trying to find what's wrong with a particularly annoying piece of code, maybe. So using them as a kind of quicker Google search, sometimes it's okay, but with lots of precaution because these tools are designed to give you a sense of security, to provide explanations that look good on the surface, but they don't have to be, okay? So, to sum up, ChatGPT and GitHub Copilot, which is the coding tool that I would recommend if I was going to recommend any, Gemini, Claude, all of these, are not forbidden. You can use them if you want to. That's your decision. My recommendation is that you do not use them, especially if you're a beginner, but they are not forbidden. But if you submit code that you don't understand, or you submit code that's obviously wrong because of the use of AI tools, you will fail the subject automatically. Okay? Any questions? Just you can ask them now, or you can let me know in web class and so on. Okay, we all need to get used to these tools slowly. Okay, go back to the course levels. As I was saying before, the beginners are welcome, and my goals would be that they learn to code in Python a little bit and understand the basics of CV, computer vision, and deep learning. Okay. We saw the data science diagram before. Data science projects happen in teams, okay? Maybe you are more into some part of engineering or biology or physics or whatever, and you don't really want to become a professional programmer, but you would like to understand a little bit about programming, a little bit more about how artificial intelligence works. That's great. This is your course. I will ask you to learn to code a little bit because that will give you a better understanding, okay? These hybrid profiles, people who have a little bit of knowledge of some more than one of the three components in the data science projects, are very important, and they are very highly sought after. So if you have substantive expertise in something and want to get a little bit better at coding to understand more this type of data science project, you are very welcome. Okay. Pro coders and everything in between. So people who are already very good at coding, who have done years of computer science and programming in different programming languages, you are also welcome. You can improve your coding skills. You can get some hands-on experience processing this, at least the drone imaging data, some structured data too, as we will see in project one, and likely the was undocumented data, even any data that you have and you're interested in. If you said, if you say to me, I would like to process this type of data, I will do my best to accommodate it and to adapt the projects of the subject for that too, okay? And you can get hands-on experience with deep learning networks, pandas. Let's see that in detail, okay? Any level is okay. Coding will be done in Python, okay? Using Colab notebooks. We will see some of them just in a second. And I already told a lot of things about coding. Going back to what we said before, the final grade is just the average of the three programming projects. I will give you a number of points and I will divide by 3. Actually, what I did last year, and I will probably do the same, is not divide by 3, but give marks not over 100, but marks over 40 actually, and not do the division. Okay, so you will be able to get up to 40 points with project 1, the same with project 2, and the same with project 3, and then you add those, so the divide by 3 is probably not going to be necessary, and you will get your final mark. Okay, and for every project I will look for progress. So if you're a beginner and you know nothing about programming and you get a little bit better for project 1, that will be very good progress, and that will be encouraged and will be evaluated positively. If you are already a pro coder and don't get much better, I don't know, that's a little bit sad. So if you do the absolute minimum, the easiest level for project 1. I will not fail you for that, but that's a little bit sad, and please do try to get a little bit better, okay? And as I said before, we have this feedback loop. You can submit, I will give you feedback, you can submit again as many times as you want. I already talked about this. The point is for you to learn, okay? So I don't recommend using AI tools if you're a beginner, for people who already are good at coding, use your judgment, okay? But I do want to leave you with one last thought. If you're a pro coder and you can only code like ChatGPT, okay, or like Claude or like the AI assistant tool, who is going to need to hire you? Okay. There are many companies that are saying AI does all the coding. Okay, those guys do not hire coders anymore. I think they are wrong. I think coders are still very much needed because the code that those tools do is very limited. I think companies that say they are only doing code with AI tools are doing probably very limited code, okay? Because I have the experience of trying to use those tools for slightly complicated code, not even anything history changing, and they cannot do it. So I think coding is at a very interesting moment in time at this moment. And I think programmers who understand what they are doing and who also understand what the tools, these AI coding tools can do and cannot do, are going to be very interesting. So probably use your own judgment if you already know how to code and see if they can help you get better. But don't trust them because probably you're already better at coding than they will ever be. Okay, and let's go with a course overview with the different levels. We have these 3 sections which go together with the 3 projects. The first one, we will do some basic programming and we will process structured data like Excel tables in that type of format. Okay. In section 2, we will do computer vision algorithms, but not deep learning yet. So we will learn about the basics of images and we will process them as quickly as possible. And in section 3, we will do deep learning. Deep learning is a part of artificial intelligence, and we will see where that is very good, where that's not so good, the things that it can do, the things that it cannot do. Okay? Spoiler alert, it cannot think. It cannot do many of the things that we see the news hinting at AI maybe being able to do. AI has no feelings, cannot have them. AI has no logic, cannot have them, cannot have it, cannot reason, cannot extrapolate, okay? But it can reproduce patterns in data very quickly, and that's already quite a lot. Okay, the first part about structured data. We will learn for beginners the basics of coding, text file input output, loops, and then we will hopefully use these basic programming skills to use programming as a way to do custom process of your data. You can just, if you have tabular data like Excel table data, you can just use Excel to do lots and lots and lots and lots of processing. That's perfect. That's nice. That works like a charm, okay? But if you can program, you can probably do the same thing and more much quicker, okay? You can adapt the code to the characteristics of your computer. You can process in parallel, and you can just, if you learn the way of thinking about programming is a new way of thinking itself, you will be able to process your data in this first project, your tabular data, much, much quicker and much, much easier, okay? For those of you already good at this basic programming, we will do pandas library. processing. Okay, and we will look at functional programming, maps and filters and all of that good stuff, and see a little bit of debugging and profiling. Okay, you already have that in the first project and in the notebooks of the course. Okay, in the second part, we will see computer vision, images as matrices of pixels. Okay, because an image is just that, a matrix of pixels. We will be able to count pixels very quickly, to use the NumPy library to process images very fast, and also to use some classical computer vision algorithms. Like, for example, we can use blob detectors, connected components. We will see in time. For those a little bit more advanced, we will see NumPy tensors. We will see OpenCV, how to combine those with pandas and achieve large-scale image processing, and some other algorithms and more sophisticated uses of, for example, the connected components algorithms. That in process 2, in project 2, and in the notebooks of the second part of the course. Okay, tell you in a second about the notebooks. Deep learning for the third and final project, what it is, okay, what AI can and cannot do, and how to train deep learning networks, and how to run them, okay, what training means and how to run them. This code gets to be pretty complex, okay? And if you're a beginner now, I don't expect you to be programming deep learning networks from scratch in 3 months' time. Don't worry. I will give you pre-made code, and I hope that you will be able to understand its main structural components and to understand how it works on a general point of view, and to run it and to do small modifications to it. Those of you that are already better at coding, we can go deeper into the PyTorch library, data sets, what those are, how we can use them, different ways of training networks, what's the difference between training, validation, and testing, okay? And if at all possible, I would like to go a little bit deep into the difference between making some pretty numbers that you can maybe publish in a paper and doing software that you can actually use for something practical. And all of the data that we will use in the course will actually be practical with real expert annotations. So that's something that's sometimes not easy to find in research papers. And if we have time, if you're interested, we will try to go a little bit deep into that. Okay. And now for something entirely different, which is not actually that different, but I have been speaking quite a lot about the notebooks of the course, and I want to go find them now. Here they are. Okay. So here they are. So these notebooks of the course, you can access them in web class in this link, in the coding courses link. Okay. You have the link to the index of the courses. Okay. Python coding for data science, and I will see in a second all the courses that are there. The videos, so some of the courses, not all of them, but quite a lot of them, have video content, okay? And the video content is linked in the same courses, but you can also find other videos in my YouTube channel, okay? This is, as you can see, a hugely popular YouTube channel with 31 subscribers, so I'm not getting rich anytime soon, but I do upload here all of my lesson videos and all of the videos I do to support the courses. So you can find lots of material here to help you understand the contents of the course. Okay, so let's see those contents of the course. These courses have two versions, the English version and the Japanese version, okay? The English version is updated first, but the Japanese version is constantly catching up. Okay, as you can see, for example, the newest course about the one about WASM notebooks, sorry, WASM document processing is not completely finished. These two notebooks are there, but these are not. Although today I received a message saying that these two have been translated. So slowly, all the material that appears in English also appears in Japanese. Okay, as I was saying, we have video lessons here. For example, for project one, and you have details about this in web class, but for project one, we will mainly be using course one and the first unit in course two. Okay, and I particularly recommend, after reading all of these basic notebooks, this bonus unit. Okay, this bonus unit is quite similar in some respects to project one. Project one goes a little bit further than this unit does, but this unit follows similar type of processing. Okay, so you have all of these notebooks. This is Colab. You have a link here to a video about what Colab is and how to use it. So have a look at that one too. But basically, if I open one notebook, I get some mixture of explanation. For example, this one is about programming basics and what programming is and how to do it, from starting from zero and explaining some things about variables. Okay, so there you can go and see and check, but you also have some code that you can run. Okay, you can modify this code and run it again, see what happens. Okay, I will show you an example just in a second, as soon as I finish this small introduction to the courses. Okay, here you have all the explanation about what variables are, how to use them, the types of variables, and you have code to run them. If you want to run code, just press play here. This code, this notebook, is running in a distributed computer owned by Colab, by Google. So you will not need to install anything to run these notebooks, okay? You can run all the materials necessary to do all the projects in the course from your web browser. Okay, not all web browsers, but most web browsers. Firefox, Mozilla, Edge, if you use that thing, they are all capable of running these notebooks. If anyone has a problem, let me know. Or it's also possible to just download them, file, download YPYMB. Do not download this one because it will be useless. Download this one. Okay, it's also possible to download them and run them in your local computer. Okay, so that is also an option if you want the code to run a little bit faster, to have a little bit more memory. For project 3, if you want to do many experiments with many deep learning networks, you will probably need something a little bit better than the free machines that Colab runs. Okay, so for students in Professor's Lopez laboratory, I know that they have some computers like the ones that you need there. For people in Yamagata, in the Faculty of Science, we have some computers that you can use for this. Just let me know and we will arrange it. And students in Yonezawa, I'm sorry, I'm not aware of GPU computers that can be accessed there easily. But if you need them, let me know, and we will ask some of the professors in Yonezawa if that's possible, how to achieve that. Okay? You do not need anything but your web browser to follow the contents of the course. If you want to go really deep and run lots of experiments and so on, you might benefit from having a bigger computer that has a GPU and can run this code a little bit faster. Okay, not necessary, can follow the course absolutely from your browser, from any computer. But if you want to go a little bit deeper, let me know and we will do our best. Okay. As I was saying, course 1 and course 2 unit 1 will be what we will be doing for the next few weeks. And for those, you do have video lessons. Okay. And you have them, if I'm not mistaken, in English and in Japanese too. Okay. So you can have a look at all of those materials. Let me know if there is any mistake, if there is any problem. And I hope you enjoy them. If you want to breathe ahead and start doing more units than following just the unit that's being done every week, that's absolutely okay by me, and I heartily encourage it. Okay, so this is it for the presentation. Okay, let's sum up a little bit. We saw what we have in web class. We explained that the language of the subject is going to be English. I see that there are no questions at this moment. Feel free to post questions at any time. We saw that the language of the course is going to be English, but that Japanese and even Spanish and Catalan are also supported. So please feel free to ask about those language support. Okay. We saw that in web class we have a questionnaire. We have this link to the courses that we have just been looking, general overview of the subject, and the announcements, where every week I will give you more details about what we will be using. For example, today we had the Zoom link and the video from last year. And for next week's session, remember, I will not be teaching that in person online at this time because I'm traveling. Okay, so for that session, you have all of those materials and you can have a look at them from today until I go back in about 2 weeks' time. Okay, the following session I will do, and I especially recommend having a look at the video of last year's session. Okay, so that's it, and that's mostly what we needed to do today. Okay, I am not going to finish the session today because I really enjoy talking about these things, so I'm going to keep talking a little bit. As I have a lesson later, just after this one is finished, I might finish this one 5 minutes earlier. But before I do that, let me just show you a little bit of the style that we are going to follow in the explanations. You can see a lot of that in the videos. But first of all, just let you know that we already have the project 1 that's online. Okay. The project starts by downloading the data and then asks you to do a series of tasks and a series of things. And we will be working with this kind of tabular data from temperatures recorded in, sorry, not temperatures, wind directions recorded in Zhao Mountain. All of this is real data, these two, okay? The course will have, the project will have 3 levels, okay? And every level will be worth, well, 30 points if you do it, if that's your first level, and then up to 10 more points if you do more than 1 level. So all of these projects are evaluated out of 40. But if you only do 1 level, you might get up to 30 points. Okay, I will post that in web class later. But you have this and you can have a look. And in next week's session, this pre-recorded session, you will see a much longer explanation about this one. Finally, what I was telling you about before, I would like to have a look at some coding, okay? Simple coding example, the type of explanations that we will use in this course. Okay, and for example, this is a very silly problem that was inspired by the Pokemon Pocket mobile game, which was hugely popular last year, not so much anymore, but still plenty of people play that. And I wanted to do this example to show you a little bit how the way of thinking that programming requires can help you address some problems and think about them differently and arrive at different solutions. Okay. So the original simple coding example was how many points to reach this master ball rank from ultra ball rank. Okay. The explanation for this is a little bit long, but basically, let me make a new cell here. Okay. Basically, in this game, you have your Pokemon cards. It's like an online version, a mobile version of the Pokemon card game. And you have your cards representing Pokemon or tools or something, and you fight, you do battles with other people. And there is a mode which is called ranked mode, where when you win a battle, you get some points, and then you add all of your points, and you end up ranked in a scale, and you get given a different type of ranking depending on how many battles you ended up winning. Okay, and in this particular situation, I wanted to know how many points, how many battles you had to do to go from the rank before last, the Ultra Ball rank, to the final Master Ball rank. Okay. The situation there is that you initially, now this has changed a lot too, but the rules are that winning a battle gets you 10 points. Okay. So you do a battle, and if you win, you get 10 points. But if you lose a battle, you lose, you get subtracted 7 points. Okay. You start this Ultra Ball rank with 710 points, and you need 740 more to reach the Master Ball rank. Okay. So the question was how many battles you need to get from this 740 to getting 710 to 1450, which was the threshold at that time for the Master Ball rank. And remember, if you win, you get 10 points. If you lose, you get subtracted 7 points. Okay, so the way we solved this was to just define initially. The first solution is something like, let's define a variable, okay, where I store my winning points, which is 10, and my losing points, which is -7, and the points that I need, which is 740. Okay, so this is a very simple use of calculation. Okay, and then I'm going to assume, let's say that because the battles are pretty random at those levels, because everyone is already very good, and it depends a lot on luck. Let's suppose that the possibility of winning is exactly 50%. Okay, so that would mean in general that every 2 games that I do, I'm more or less expected to win one and lose one, and that would mean that my expected points become my win points minus my loss points, or plus, because we already put the minus here. Okay, so if I do that, the number of matches needed correspond to the expected points that I get. Well, the number of I need to divide the points needed but by the number of points that I get. Okay, basically the expected points for every 2 matches are this 10 minus 7, So I get basically 3 points for every 2 expected matches. So I need to do the number of matches that I need are 2, because this corresponds to 2 matches, multiplied for the points needed and divided for the expected points. Okay, this was really not a brilliant explanation, but the point is that if we just assume 50% win chance every 2 matches, in general, I get this number of points, and then I just need to divide to get the number of matches that I need, and I get an answer that's 493. Okay, so I run this and I always get the same answer. And this is a very simple way of solving the problem. Okay, and I only need it to do addition, subtraction, and multiplication and division with Python. I also use the Python print statement. So this was very simple code to get a general idea that gets me in the ballpark of what I want to do. Okay. So using just a little bit of Python, I can get an answer for my problem. However, that's not a very good answer, because in general, I'm not going to be getting 1 win and 1 lose always. And more than that, I'm not really simulating the process of playing different battles and winning or losing. So I can do a code that's a little bit more complicated to simulate that type of outcome. Okay. And here we were proposing this second code. What we did here was first define a Python function. Okay. If we go back to the courses with the with unit 1, you can basically do this simple, easy code. Okay, with unit 1 and thinking. Okay, and if you can think about this way of solving the problem for this very simple code, for example, an AI tool will completely work. Okay, if you ask the AI tool to do the thinking for you, that's probably not going to happen, because AI tools absolutely cannot think. They will look like they can think. If you ask them to think, you will get an answer that it will look like they have done some thinking, but they haven't. They cannot. They have nothing to do thinking with. Okay, so they will maybe trick you into thinking that they have done some reflecting of their own, but they cannot do it. Okay, so if you do the thinking for the AI tool and ask them for a code that does that, they will probably be able to do it. But as the code is not very difficult, you will be better off if you do the effort to do the code, because that will help you do more complex code later. With this, we need a little bit more. We need functions. Okay, so we need to go probably understand a little bit about Boolean, and there will be a loop. So iterative programming and writing our own functions. So to write this code, we need notebooks 1, 2, 3, 4. These are pretty easy notebooks. So I recommend you have a look at all of them as soon as possible. Okay, and we can define these functions: battles to next rank. And they have parameters, points for a win, points for a lose, win probability. We said always win probability is 0.5. Here we have that as a parameter. So maybe yes or maybe no. And a start and end. Okay, here I had hard coded the values that I needed, the points that I needed. And here I can change them in my parameters. Okay. And what I'm going to do is that I'm going to have a loop. While my points are smaller than end, okay, so I will start at 1 value of points that I will receive as a parameter. And while I haven't reached the end, I will every time generate a uniform, using a uniform distribution, generate a probabilistic value. And if that's smaller than my win probability, then I will add 1 to my points. Add the percentage of the points for winning to my points. If I lose, I will add my points, losing points to my points. So basically, in this while, what I'm going to do is that I'm going to repeat at every iteration, I'm going to either add or subtract points depending on a random draw. Okay? In the first case, I heavily simplified the problem by assuming, okay, 1 win, 1 lose. Here, I'm not doing that. I'm doing a random draw at every step, and I'm feeding it whatever win probability I want. Okay, so this is not super complicated coding, but this mimics the actual process much better. Okay, and then I have a variable to count inside of this loop, and then how long that took. Okay. So here I'm going to put a number of repetitions, let's say 100, and I'm going to call this battles to next rank function a number of times. Okay, here I added the points for a win 10, the points for a lose -7, the winning probability, I also included 0.5 and the start and the end. Okay, and here, for example, I get an answer that says that on average we needed 495.34, okay, to reach the next rank, okay? I can do, instead of 100 simulation, 10,000 simulations, okay? And now I have done this 10,000 times and then computed the average. I have done 10,000 simulations and computed the average. To compute the average, I used least comprehension here, and I use the mean Python built-in function, okay? So beginners, after reading some code, you should be able to understand this, and we will use this type of coding a lot, okay? After doing what we will need for most of what we will need for unit 1, you should be able to understand this. And then this is just a little bit more complicated, a bit of an advanced programming technique. Advanced coders will probably be familiar with least comprehensions. This can be done with a for loop too, okay? My point here is that we can modify, we can use coding to think about problems and get very effective results very quickly, okay? And if we know a little bit more about coding, we can do pretty faithful simulations for simple and, as we will see during the course, even very complex coding, okay? You can do things in Excel, but I don't think you can do 10,000 simulations of this problem with parameters that quickly, okay? And on and on it goes, okay? I will leave you with the proposal to complicate this a little bit, okay? For example, there is something called win streaks. So in this game, the rule is also that if I win 2 times in a row, not only do I get 10 points every time, 10 plus 10, but I also get 3 extra points after a second win. If I win 3 wins in a row, after my third win, I get 6 extra points, and so on and so forth, until I get 12 extra points after my 5th consecutive win, and my 6th and my 7th and my 8th consecutive win, okay? How would you implement that on Python code? Okay, think about it. Maybe ask an AI tool and see what it does. Maybe able to do it, probably not sure. Probably the code that an AI tool makes is going to be a little bit too long here. See if you can do it shorter, see how you would implement it, okay? And if you're interested in my opinion, just send me the code. But the point is that we will use this type of thinking about coding to get code that helps us process data from the course, and if you're also interested, data from your own research. Okay? So that was it from me today. I'm going to stop sharing now. Well, let's see. Yes, I stop sharing now. Uh, this is, as I was saying, the end of my speech for today. In the class after next class, remember, it's recorded, but from the class number 3, we will be doing this kind of session. Remember that you can interrupt at any moment. Are there any questions at this moment? You can ask questions anytime you have them, okay? No questions here. Let me check if there are any questions in web class 2. Not at the moment. Okay. And you can also ask questions in Slack. Okay. The Slack, let's keep it more for asynchronous communication. So if you have any questions that you want me to answer at some point, you can also ask them in Slack. You can join the channel and there will be a dedicated thread for that in Slack. And I will read that in my mobile phone, so you will reach me quicker. Okay, so that's it for today. This is the presentation of the subject. You have the questionnaire for your general knowledge and you have project 1 already, okay? See you in 2 weeks. And if you have any questions meanwhile, just feel free to send them to me, okay? Thank you very much.